Right, okay. Well, I'm going to make a start because we're so tough on time. So welcome to our Plastics in Construction Dragon's Den, everybody. So this is the first in a series of exciting events, and this one is has a focus on insulation. So this is the program. So we've got an hour and a half together. So we're going to have 5 minutes from me, and then I'm going to hand you over to my colleague Catherine Adams, who's going to launch our Plastics in Construction guide. And then at that stage, we're going to have talks from our invited dragons. So I have John Williams with us, and his senior partner at Sinvestec, which is an investment company specializing in clean and renewable technologies and the bioeconomy. We have Mark Lynn. Give us a wave, Mark. Thank you. So Mark is Vice Chair of ASBP and Managing Director at Thermofleece, which is sheep's wool insulation. And Jamie Page set up the Cancer Prevention Society in 2001, and this was after a career developing and commercializing therapeutic proteins. And so tremendous experience from our dragons that we'll share with you. And then we'll move on to the pitch sessions. And so we've got 3 pitches here. So we're joined by Ehab Syed from Biome. So perhaps give us a wave, Ehab. And we've got Rosalie Riklova from Thermilon and Steve Ruggia from GeoCell. So if you can just give us a wave, and then we'll ask you to turn your cameras off for the moment, and I'll just have a whip through a few slides. So just a few guidelines. We're going to take Q&A through the hour and a half. So just put your questions into the Q&A. Don't use the chat unless you've got technical problems, and please don't raise your hand because we're not looking at that. So we'll have time for 1 or 2 questions after each dragon and after each pitcher. So if you've got questions, pop them in the Q&A. Please make sure it's clear who you're asking the question of. We've got pitch videos from everybody, 2-minute videos, which we'll all watch together. I'm hoping that they'll play okay. And we are recording this, so if you don't want to be recorded, please turn your camera off. Your camera's all going to be off for the moment anyway. So who are we? The Alliance of Sustainable Building Products is a not-for-profit mission-led membership organisation, and that's our mission there. So we're not a trade association, we're a slightly different organisation to that. So our focus is on products, and our strapline is healthy products, healthy people, healthy planet. So we organise events, and we participate in research projects, and we've got sort of 3 main themes which we weave together. So health and well-being, resource efficiency, and product sustainability. We've got 70 members now. It'd be good to see your logo here. But we've got a really broad church from across the construction sector, which is really exciting. Thursdays is our day for doing events. So we've got weekly events on Thursdays now, all the way through to the summer. And next week, we've got a subject close to my heart, measuring and monitoring of indoor air quality and healthy buildings. Should be a really fascinating insight into that. And I'm really pleased we're joined by Professor Stephen Holgate on the 9th of July, who's going to run through the inside story with us. And that's a great document, and it puts together all the research we have on indoor air quality and children's health in one place. So this will be some really interesting lessons for everybody from Stephen. We've got masterclasses, so much more intense look and much more interactive. We've got 2 hours, we're limiting attendees. This is with Jane Anderson, who's a life cycle analysis guru, is how I describe her. And this first one we have in July is on biogenic carbon or sequestered carbon. And we're going to be looking at that in some real detail. So consider signing up to that. My colleague Catherine, I'm really pleased, is speaking at an event with Nature Plus, where members of Nature Plus, it's a European eco label. And so we've got a webinar with across Europe, trying to understand how a circular economy is being encouraged across Europe. And we've got an event with SIBC looking at the embodied carbon of building services on the 23rd of July. So another one for your diary. So do get involved with ASBP. We do rely on our members to help us and through our work. Sign up for our newsletter. Think about being a sponsor or joining one of our groups. And we hope to see you on our webinars coming up. So this is our contact details here. So at that point, I'm going to hand you over to Catherine, who's going to talk us through the Plastics in Construction group and launch our guide. So Catherine, if I can ask you to share your screen.
Hi everyone, can you see my screen? Yes? Let me just,
yes.
Thank you. Hi everyone, so I'm Catherine Adams. I'm just going to spend a few minutes just giving you a bit of context about why we're doing the Dragon's Den event today and our work in plastics in construction, and then most importantly launch a guide that we've been working on about plastics in construction. So let's go down, next slide. My slides don't want to go, don't want to move. Oh, no, it is. So we first started talking about plastics in construction in some detail at an event, our Healthy Buildings. This is our annual conference and exhibition. And the one we did in 2019 was very much focused on plastics. Some of you may have been there. And we looked at various issues related to plastics. So some of this was related to pollution and the problems within the marine environment. Some of that was related to health impacts, both in terms of ingesting it and potential harmful effects in fire, and then the whole waste issue as well. And then you can see our keynote speaker there, Emily Penn. Do check her out if you haven't, because she really is quite inspirational. So from that, we really thought we need to do a bit more on plastics. So we set up a group, and I'll talk you through that now. And when we first set up the group, we tried to work out what people's interests were in plastics, quite wide ranging. Some interested in the single-use plastics and the packaging agenda, others looking at more longer life plastics and looking at alternatives to plastics, how you can substitute them and move away from plastics in certain applications, so not necessarily all plastics. Some more interested in the nurdles. They're the very, I think that's a picture there in the hand, very small bits of plastic, which can become quite, come from the manufacturing process. And different things like leverage, position and influence, and really just having a better understanding of what happens to our plastic waste. So we set up this group. I think we've been running for around a year now, or maybe even a bit longer. We're very collaborative. We're across supply chain, which I think works very well in that we can all understand each other's issues and have a better appreciation of them. We want to remain small because that means we're nimble and we can be quite agile in that. Very much identifying challenges and looking at how we can address them. And we meet quarterly. And I think we've got a meeting next week. So what our plastic groups members are all active in the plastic agenda. Free Adapt, they may, some of them may also be listening today, hopefully. So Free Adapt, the lady that worked there, organised a very big event in Bath looking at Ocean Plastic Day. Half of that was based on schools and half of that was sort of, based on the community. Mace have been doing a lot of work on their sites with a campaign on Time to Act, focusing very much at reducing single-use plastic in the canteens and packaging. We have an Interreg project, so Charm is carrying out an Interreg project. They're a housing association and really excitingly trying to develop virtually plastic-free houses. They may be completely free plastic houses, I don't know, I haven't spoken to them for a while. And then we have other members that are really sort of producing products that do not contain plastic or very, very low amounts of plastics, and you can see examples there of windows, guttering and blocks. So in terms of what the group has been doing for the last year or so, you can see this sort of flow diagram here. So each activity builds on each other. So we very much want to create knowledge and learning, and that's what we've done today in terms of develop this an interactive guide, which I'll show you in a minute. We've done a stakeholder mapping exercise as well, which I'll quickly show you. Very much about engaging and educating across the entire supply chain on what alternatives are out there. And today we are doing the innovating bit. So that's very much hosting this Dragon's Den to look at what alternatives are there and how we can encourage innovation. And last but not least is really then trying to find an avenue for these products to be piloted and really prove that they do work. So this is our stakeholders and activities map. You can find it on the link there. It's quite a clever map-based system. Do let us know if you're not on there or you want to be on there, because this is only as good as the information on there. So it holds information on stakeholders working in plastics in construction, and it links to their activities, and it's a little web of linkages, if you like. And it's got a very good interactive search function. So today I want to launch our introductory guide on plastics in construction. It's an interactive guide issues, and as you can see with the big question mark there, it is a question and answer guide. So for example, under each section there's a question, and then we hopefully provide an answer to that question. And the main sections are: why are we focusing on plastics in the first place? So that includes elements such as what types of plastic is used, how much is used, in what type of applications, what happens to it when it becomes waste, how much recycled content is there. And then in terms of what are the issues with plastics, what are the alternatives, are there advantages of using plastics, what about bioplastics, which can be a bit of a tricky issue, what's being done. So we've tried to sort of encompass the work that we know that's being done, but do let us know if we've missed anything on that. We very much want this to be a living guide, so we will welcome your feedback, and we will try and update it as much as we can. A bit about us and why we're focused on plastic and who's involved in the group, and then also the drivers in terms of looking at what the drivers are for packaging, for looking at sort of plastics in construction, and the drivers for reducing it. And we have tried to focus very much on construction. We're very much aware that most of the work that's being done on plastics is in the single-use environment in the consumer-led area. So this is really trying to focus on construction, both single-use and longer-lived plastic. And it's free to download, so please do have a look and give us your feedback. And there you go, that's an example of I didn't say how it works, sorry about that. So what you do, it hyperlinks through to a screen. If you press on each question, the screen pops up, and you can see that we've tried to hyperlink as much information as possible on it. So just to finish off, this is our first Dragon Dens event, but we're having a series of them. So you can see listed there that we intend to run another 4 of these. So our next one is in Thursday, the 17th of September, focused on the single-use plastics and packaging agenda. Then we have one in October on building services. November, flooring, finishes and paints, and then finishing off in December on building elements. The intention is then for each of the winners from those Dragon Den events to be in a grand final in 2021. So anyone who's got a product within those categories, which is under development or near market ready, then please do get in touch, because we would love to hear from you. And just to say quickly, these are the membership. These are the members of the group. So I said we were across supply chain. I won't go through them all, but I haven't got time. But they've all very much helped with the guide, and are very much engaged in all the activities we do. And there is a small membership to be part of the group. So get in touch if you'd like to become more involved. And with that, I think that's me done. So I'll hand you back over to Simon, I think.
Thanks, Catherine. Yeah, that's great. Really useful. So we, true to form, have been editing our guide right up to the very last moment. So it's not quite there on our website as we speak, but it will be by the end of the webinar, I hope. But so now let's talk to our dragons. So without further ado, I'll introduce you to John Williams. John, if you can put your camera on. And so John has a lifetime of experience of investing in the bioeconomy. So I'm eager to have some insight from you, John. Thank you very much.
Thank you, Simon, and welcome to the virtual audience. I'm delighted to be invited to this event and also onto the panel as a dragon, hopefully a reasonably constructive and friendly dragon. Just a little bit of background for me before we get to describe Investec. Is my background. I'm a polymer chemist originally, so I worked on the petro side of the industry for some 20 years or so with Henkel, and ended up leading Total's initiatives in Europe on emulsion polymers. I subsequently, when I left Total, I formed a small development company to develop what became bio-based and sustainable materials, particularly around adhesives and surface coatings, and subsequently sold some of that technology to Procter & Gamble. As part of that sort of process, I joined the National Non-Food Crop Centre in York, and initially just to find a little bit more about the policy frameworks and direction of travel for the renewable and sustainable sectors, and actually ended up joining them formally and as head of materials, and stayed there for 7.5 years, which was a fantastic time, in fact, because I learned so much about bigger areas outside of my technology area. And in terms of construction side specifically, I helped form the group of renewable construction materials within the NNFCC, which I think still contains some members of this group. And we got involved in things like, in the heady days of DEFRA money and DEC money, courtesy of Iris Anderson at the time, and within DEC and DEFRA. We got involved in building the renewable house at BRE and subsequent programs coming out of that. We did natural fibre LCAs with Imperial College for insulation materials. So there was a lot of crossover activity in the material sector, which became extremely useful for me. What that brought to the party was I was already, and had been for some time, involved in some investment groups that were looking around sustainable propositions and possibilities. And that really crystallized in around about 2010, 2011 with the formation of Investec. Because what Investec is we try to be a bridging investor in essence, as in there's always the cliff of death, particularly associated with early startups and disruptive technologies, where you may have early investment or even using your own money or angel investment. But there always comes a point where if you get successful and you're trying to expand, then bringing in institutional investors, private equity, venture capital, always becomes a bit of a stress and strain. And in fact, in a lot of cases, a lot of companies simply run out of money trying to get to that process, and a lot of ideas are wasted in that process. So Investec's idea was to cut out the middlemen, in the sense of we will go relatively early in our investments. These investments are around sustainable, renewable and biotech, not necessarily particularly directed towards energy and fuel, but much more towards materials and other biotech, for example, platform chemicals, performance chemicals and specialties. But what we try and do is we aim to stay in for a medium to long-term investment proposition and allow other investors to come in and out, which makes the institutional investment proposition as the company gets larger much easier to deal with. And you're also only dealing with one shareholder, because we represent our high net worth individuals who simply place the money through Sinvestec. So Sinvestec becomes the shareholder, not any individuals, because nothing hog-ties a company more than having lots and lots of shareholders, because that certainly causes difficulties going forward. So what we've tried to create is a platform that allows quicker routes to expansion and money, and also to try and connect technologies together, which we try, that's part of my job, is to identify technologies to invest in, but also to see where there are synergistic technology crossover points where actually there may be, you know, indirect collaboration or direct collaboration, or even joint development and formal collaboration. So which again drives this sector forward. We operate globally. We have investments in North America, Asia, Australia, and actually laterally in Europe. Europe came a little bit slower than the others. And I'm directly involved at the moment on the plastic side in a company in Birmingham, which was created or formed in 2014, called Aquapack, which is answers some of the problems that actually Catherine's alluded to. So it's a hydrophilic plastic material with primary barrier properties and good end of life, including marine biodegradability and non-toxicity. So there's a lot of, as you could imagine, a lot of activity in there, which is why I'm spending a lot of my time at the moment on the board of that company. So
you have 2 minutes. You've got 2 minutes, John.
I'm nearly there, Simon. Actually,
okay.
In essence, that's the summary. Just an overarching introduction. Really looking forward to the pitches and seeing what we can do.
Excellent. Thank you so much. That's really interesting. We must kind of have a beer sometime when we're allowed to. All right. So thank you very much for that. So Mark, I'll ask you to share your screen. And so Mark is the Vice Chair of the Alliance of Sustainable Building Products and does lots of work for no money, which there is a theme that runs through ASBP for that. And he's also Managing Director at Thermofleece. So thank you very much, Mark.
Thanks, Simon. Well, that's a good introduction. Just to add to that, I'm a chemist with a background in material protection, and I've been in the natural insulation business for about 15 years. I run the business that's behind Thermofleece and a few other natural fibre insulation brands. And I have the scars to show it. So as being a member of the ASBP, we're a member of the Natural Fibre Insulation Group, which is a sort of collaboration of some leading natural fibre insulation brands in the UK, and we're just aiming to promote the benefits of natural fibre insulation throughout the UK. Go on the ASBP website, the Natural Fibre Insulation section, you can see some of the briefing notes and other resources that we've generated. And the title, I'm just going to run through a few slides really in terms of the multiple roles of insulation. I appreciate this as an innovation event, so you know it's important that we tie in the multiple roles of insulation into sort of innovation framework. Because I think that insulation in many respects is viewed as a one-dimensional product, when in actual fact it can comprise at least 50% of the
Mark, sorry to interrupt. Will you do a favour and just check that your microphone, your speaker, everything is you're sort of coming in and out a little bit.
Yeah, can you hear me okay?
That's better, yeah, thank you.
All right, okay. So yeah, I think natural fibre insulation has been seen as a very one-dimensional product with a focus really on energy efficiency. But there's a lot more to it than that. That's important when it comes to innovation as well, because it gives you many more aspects against which you can innovate. So you can see here that you've got, on the one hand, you've got the thermal aspects, but of course you don't just have the energy loss or the heat loss, you've got the heat gain aspects. You've got the acoustic elements to insulation, buildability, durability, impact on health. That's something that's quite low on the agenda at the minute. It really needs to be much, much higher up. Fire protection is a very salient subject at the minute. So I think one of the roles of certainly the natural fibre insulation group and the companies within it is to really try and emphasise the importance of this sort of multifunctionality of insulation. So multiplicity, if you like, drives innovation. So if a product does more than one thing, you've got multiple routes for innovation. If a product does more than one thing, you've got multiple routes for differentiation, and also you've got multiple routes for complementarity. Now, I've been in the insulation business for 15 years, as I've said, and it can be quite a confrontational industry where everyone is claiming often that their product can do everything better than anything else. And there's very little innovation in terms of using various products in combination to maximise the strength of one particular product and the strength of another particular product. It's very difficult to have your cake and eat it, but it's quite easy if you've got more than one cake. Just to sort of illustrate again this different aspects where innovation is necessary, I've just put a sort of benchmark diagram up here. And these are sort of aspects of insulation and benefits and performance. And you can see on the top right-hand corner here, you've got the thermal conductivity, the lambda, and that's a very well-defined problem in the market. But interestingly, if you look to the top left, you've got the R value. Now, the R value is essentially describing the same problem, which is energy, the energy efficiency of the material. But what the R value does is describe it in a different way. Now, the market understanding of the R value is very low at the minute, whereas the market understanding of the lambda or the K value is very high. So what does that mean in practice? Well, it means that in the UK at least, people are drawn more to materials that have ultra low or low thermal conductivities or lambda values. Because the R value, which is the reciprocal of the U value, because the R value isn't well understood in the UK at least, it's sort of, it gives materials that don't have particularly ultra low thermal conductivities. It doesn't really give them an opportunity to perhaps explain the performance level of that product, because what the R value does is take into account the thickness of the insulation. So in markets like the US and Australia, insulation is sold on the basis of an R value. So you're able then to the consumer to see in a much more straightforward manner how well insulation performs, and they're not just focusing on the low K value. Where are the opportunities for innovation? Well, if you look at the minute, breathability is something where the problem is poorly defined and the market doesn't understand the concept that well. If you ask 10 people about breathability, you'll probably have at least 5 different definitions of it. And you'll probably be no clearer than you were at the start. So I think there's certainly need to innovate in terms of really defining the problem of breathability more in ways that people can understand, and try and increase awareness in that respect. Fire is a subject where the problem definition isn't fully defined at the minute. I think that debate post-Grenfell is ongoing. But the market understanding and acceptance of the issue is quite high. So again, you can just see here the different aspects of insulation and different opportunities to innovate. Now, where the market at the minute is gravitating towards is very low thermal conductivities that allows low U values within building fabric, but who's to say that's going to stay that way forever? So if you're looking to innovate new building materials, maybe the areas towards the bottom left are where the potential opportunities are. If the problems can be more clearly defined and the market understanding increased. Just finally, just to emphasize that point, on the subject of innovation, multiple roles of insulation is very important. We don't see insulation as a one-dimensional material. It gives multiple roles for innovation. And we also have to bear in mind that when we're talking about innovation, we can't ignore the sort of simple incremental innovation. So things like using technologies and combination. And also innovations in workmanship, because it really matter how sustainable a product is or how high performing a product is. If it's installed badly, that's all wasted. And these are all innovations that need to happen in the marketplace. So I'm looking forward to hearing the pitches from the 3 companies that have that are presenting this afternoon. I've had a look at research each of them, so I'm keen to hear what they've got to say. And thanks again.
Thanks for that, Mark. Yeah, sorry we had a few sound issues there, but Mark's in the middle of rural nowhere. So thank you very much, Mark, for that. So Jamie, I'd like to welcome you to the stage, if I may. So Jamie Page has a career in developing therapeutic proteins and has been working for the Cancer Prevention Society since 2001. So if you want to pop your camera on, Jamie, and unmute yourself and share your screen, we'll be able to run through your presentation. Whilst Jamie's getting ready, if you've got any questions for any of the dragons, just pop them in the Q&A and we'll try and look at those as we go through. So Jamie, are you there?
Yes, I am, Simon. Can you see my screen all right?
Yes, that looks superb. Thank you very much, Jamie.
That's great. Thank you very much for having invited me today, Simon, to speak at this Dragon's Den event, and thank you, ASB. So I'm going to be telling you as quickly as I can in a relatively short time about flame retardants. Basically, flame retardants divide into 2 categories, halogenated and non-halogenated ones. And for those who, yes, I need to apologize. I'm a chemist too. It's more like a Royal Society of Chemistry meeting than an architects meeting. But so the chemicals divided into 2 categories, and halogenated means that they contain, in this case, either chlorine or bromine. And there are different brominated and chlorinated flame retardants. And then now there's also moved towards the so-called non-halogenated chemicals. These are chemicals that don't have either chlorine or bromine in. And there's some preference towards that now, because when you halogenate a chemical, you actually increase environmental persistence. Now, where are they used? Well, they're used in building insulation, furniture, textiles, computers and electrical goods, and vehicles. The amounts of flame retardants that are used worldwide are very significant. So, for example, one organophosphorus flame retardant, a high volume one, TCPP, in Europe, 36,000 tons were used, and that was already quite a few years ago. Last year, they estimated the amount of organophosphate flame retardants in China being used in new buildings to be about 24,000 tons. And the amount of flame retardant typically used in a foam is probably 8 to 10% by weight. Now, you may be thinking, well, buildings use tons and thousands of tons of materials, but I'll be telling you about the health effects in a moment. So health effects are in very low concentrations, and I'll tell you about that in a sec. So where are they found? Well, they're found, they partition to air, dust, surfaces. They're found in our food that we eat, particularly meat and dairy and fish. They're found in breast milk, maternal mothers. They're found in oceans and lakes and all the wider environment, including marine animals, fish and birds. This slide shows how they partition differently between air, hand wipes, floor dust and surface dust. So depending on the molecular weight of the, in this case, organophosphorus flame retardants, you'll find different ones in different places. This slide, which comes from the UK, study done a few years ago, this shows how the flame retardants, you find different levels in different situations. So in classrooms, motor cars, living rooms and offices, you get different amount of flame retardants appearing. What's striking about this slide is how much is actually in motor vehicles when you think what an enclosed space that represents. Our charity is a health charity. We predominantly focus on health effects of chemicals. We were set up to reduce impact of these chemicals on human health. I have a background in medical biotechnology and pharmaceuticals, but I strongly believe, that's why I founded the charity 20 years ago, that we need to be reducing human exposure to harmful chemicals. It's not just enough to have early diagnosis and treatment, which is the way society is generally set up in healthcare. And there's a big literature reporting health effects of chemicals. The evidence-based is in vitro, in vivo, and human data. And we have a whole raft of health effects being reported for flame retardants. So just to quickly skim through this, you know, there are literally tens, if not hundreds of studies behind here. Developmental, behavioral, and neurotoxic effects, endocrine effects, in plain English that means hormone effects. That includes effects on the thyroid system, on this, on carbohydrate metabolism. That's affecting things like diabetes and obesity risk. Some flame retardants are suspected as being carcinogens, causing cancer. There are reports of cardiac effects on the heart, liver effects, that's hepatotoxicity, and other effects as well. The impact of flame retardant use is not trivial. So for example, an analysis done of just PBDEs, which is a class of flame retardant that's now phased out, they estimated that there were a cost of $266 billion. And that was reported in a journal called Lancet Diabetes, which is quite a well-respected journal. But the other issue associated with flame retardants and foams is that some products contain a lot of nitrogen and are highly flammable. And so when they burn, they form cyanide gas, which incapacitates people, which is a very serious problem. And some of these flame retardants, it seems, because they slow down the time to flaming, you get more what they call products of incomplete combustion. So you get more cyanide, deadly cyanide, and more soot. And soot, I understand, is very problematic, particularly for the firefighters, because it doesn't allow them to safely move around a building to put out the fire. Apparently fires in the old days, in sort of 20, 30 years ago, were much cleaner and brighter to move around. So there's been a change due to the modern materials being used. I won't go through this slide, but there's a huge presence of these flame retardants in the wider environment. So you have them in the Antarctic, you have them in penguins, you have them in lakes, you find them in Mediterranean fish, the Indian Ocean, whales, and so on and so forth. And what this shows is that flame retardants that we're using in our cities in Europe, say, these are ending up in the wider world. So we're actually having a global impact here, a bit like these microplastics that we hear about all the time. Another issue is that when these flame retardants are recycled, they end up coming back into our circular economy system, often in objects. For example, this study that was done in the Czech Republic, they found a lot of flame retardants in children's toys and kitchen utensils, things like back spatulas, which gives you food for thought when you're, frying your eggs or whatever you're doing. Another huge issue is that flame retardants, it's very hard to know for recyclers what flame retardants are actually in the product. So if the flame retardant is banned, as they often are slowly over time, when it comes up for recycling, how does the recycler know what flame retardant are in it? So we're calling for permanent and never deleted records to be kept of the flame retardants that are used in products. So in summary, the issues are the health issues, the fire toxicity issue I touched on briefly. There's the environmental contamination of animals and water systems. There's the recyclability problem. And last but not least, there's the difficulty of removing the products when they're banned. So furniture's bad enough, but building insulation, as we know from asbestos, if you have a problem, it's very hard to deal with. So we have to be very mindful of what we're actually putting behind our walls when we build buildings. So in conclusion, there's a need for environmentally friendly materials which are not highly flammable nor fire toxic. That's the first thing. And if you do that, and I'm a great believer in industry putting pressure on the chemical industry, so people making insulation panels, designers and things, you can be giving briefs and specifications to industries, but they need to be coming up with, a lot of these foams are quite old. My first job I worked on in the 80s, I worked for the ICI polyurethane division. People are often talking about innovation, but we genuinely do need some innovation here. And of course, natural materials are often naturally very fire toxic, and we'll be hearing more about those maybe today. And this would reduce the need for flame retardant. I've got some websites here with more information that you might find useful. And thank you for listening. I've ran this into 8 minutes. I hope I managed to do so.
That's fantastic, Jamie. Thank you very much indeed. That's bang on the nail. So I hope you'll agree. We've got a bright bunch of dragons for us today. And so if you've got any questions for the dragons, then just pop them into the Q&A. As I say, try and make it clear there who you're asking the question of. We will be sending around the presentations and the biogs and the video after this event, so you can always catch up after the event as well. So now I'm really excited to say we're moving on to our pitches. So now we are going to look at their videos. So Biome is first, and so we're going to play their video. So we know the internet connection may mean that it doesn't play that well. It is, they are live up on our website just now, but hopefully the quality will be all right. So Richard, if you can share your screen, and we'll watch the Biome video, and then I'll introduce EHAB, and we can do some questions and answers. Thanks, Richard.
Just bear with me. Can you see this okay?
Yeah, that looks good. Thank you.
Good start.
Is a multi-award winning research and development-led company that allows nature to lead innovation. We truly appreciate nature's genius and place biological systems at the heart of our inspiration.
To revolutionize our built environment and the way we do business.
We harness the power of mycelium,
the filament root structure of mushrooms,
to make materials. We feed our mycelium organic and synthetic waste streams or byproducts from a variety of industries.
So not only are we creating new advanced materials, we are also helping solve our ever-growing waste problems and all the impact associated with that. We are working with over 300 different species of mycelium.
And we're training them to consume anything from food waste, construction waste,
fashion waste, and even plastics.
There have been a few breakthroughs in the lab recently, and we've won the Waitrose and Partners Plastic
Prize to continue developing our plastic-consuming mycelium strains,
creating sustainable alternatives to our construction industry's most damaging materials.
Our mycelium insulation is demonstrating unbeatable performance properties.
It's fire resistant, it's outperformed leading building insulation products,
offering advanced levels of thermal and acoustic insulation.
It consumes waste and carbon as it grows,
and creates healthy, breathable homes.
Each biomanufacturing facility we set up will provide enough material for up to 120 homes per month.
This means that every month, the production of our materials in one small facility can use up to 150 tons of waste,
storing a minimum of 16 tons of carbon as they grow.
So just imagine the impact as we scale. We are an international team with ambitious global aspirations.
And we aim to grow bio in an ethically sound fashion.
We are setting up the world's first
community-led biomanufacturing facilities
in collaboration with social enterprises like the Onion Collective and the YMCA,
aimed at regenerating and enriching local communities
through the equitable distribution of benefits.
And we are working closely with the world's largest corporations,
the world's top universities,
and the world's most prominent governments.
And of course,
with local communities,
local resources,
local businesses, globally local.
Fantastic.
I hope that wasn't too weird.
The stand was okay.
Good.
But yeah, Ehab, so perhaps if I can ask you to turn your camera on, and perhaps if I can ask the dragons to turn their cameras on as well and take their mutes off. So we've got 10 minutes now, 5 minutes with the dragons and 5 minutes with the audience. So I'm going to go down the dragons in the same order. So I'm going to ask John to ask a couple of pressing questions, and then Mark, and then Jamie. So over to you, John.
Thank you. Ehab, impressive video. Thank you for that. The feedstock, what is it? You sort of kind of rush through a little bit there in terms of, you know, is it heterogeneous? Can you mix it together, or is it has to be, you know, in streams? What's the plan?
So we evolve all of our own strains of mycelium, which means that we can train them to consume different waste streams. Certain strains are able to consume particular waste streams much better than others, and we're able to evolve them to improve that ability. The facility that we're setting up in West Somerset, which will be live by the end of this year, is going to be consuming things like hemp shiv, agricultural waste streams from things like straw, grass trimmings, also wheat byproducts, and we're also going to be looking at paper and cardboard. Those can be mixed together with certain strains, and with other strains they would have to be separated. Depending on the waste stream that is used and the strain that is used, you can achieve a variety of material properties, and we're able to tweak that quite with a lot of control in order to achieve such high performance.
Okay, so does the end product you're aiming for vary by the feedstock input, or can
so
you tweak it?
We're going with BBA accreditation, and we're having to abide by standards. So we're going to be using a specific waste stream in each facility, and then as we expand, we will add on versions onto the accreditation. So, so because of that, each waste stream will vary slightly the performance, but it will all be accredited against standards before it's commercialized.
Okay, I think my final question would be, what's the energy balance of the process look like? Is it, you know, efficiency wise, what does it look like?
So it's an incredibly low energy process because you're working with living organisms and very little and like forceful machinery. They're doing most of the work. So all you really need to do is monitor the environment. So if you look at, for example, vertical gardening, it'll be a similar type of energy usage, but we don't need it to be as intensive, and you don't need any light, for example. So yeah, it's a very low energy process compared to anything else that's producing similar materials at the moment.
Thanks, Ehab.
Thanks, John. All right, so Mark, I wonder if you can quiz our picture.
Yes, thanks, Ehab. It was a nice video.
Thank you.
I guess being in the insulation business, one of the things that I was immediately drawn to in your video was a thermal conductivity of 0.024.
Mm-hmm.
Someone that's been researching natural fibre insulation for quite a long time, we've always hit a floor of about 0.032. So when you produce a figure of 0.024 for an open cell structure, that is sort of blowing conventional wisdom completely out of the water. So how confident are you in that number?
So that number is based on university tests that we've done using the insulation panel that we're going to be producing. We're going to be doing tests with a variety of different processes. We expect it to obviously fluctuate a little bit, but because of the very sort of interwoven web that, or of air pockets that the mycelium creates, you're basically using the thermal conductivity of air as a as the thermal capacity of the material. So it's really, the secret is in the structure that the mycelium creates within the material internally.
And that's a repeatable value, is it?
It has been so far, but when we do the accreditation testing with BBA, that's when we can be 100% sure about that.
And just one other question really, which relates to the dimensional stability of the materials, particularly as humidity varies. How's that?
Mm-hmm. Yeah, so the beauty of mycelium is you can create a variety of different dimensional stabilities. So this one you can see is a little bit flexible, whereas something like this, for example, is completely solid. Yeah. And that's dependent on the strain that you use with the mycelium.
I guess when I say dimensional stability, I'm thinking more in shrinkage as humidity varies.
Yeah, so we're actually undergoing all those tests at the moment with BBA. I haven't got values for you at this stage. We've done a lot of in-house testing, and that has been incredibly promising. So all of the mechanical testing that we've done has shown that it's either in line with other market products or outperforming them.
And just one last question. When do you plan to launch your first insulation product?
So the facility that we're setting up in West Somerset with the Onion Collective, a social enterprise, that's going to be operational around August, so in a couple of months. And by the end of the year, it will be open for sales and for the industry to take part in. We just need to run a few pilot production runs first, just to make sure that everything is as we expect it to be.
Thank you.
Thank you. Excellent. Thank you, Mark. Thank you, Ehab. So keep your questions coming in. So we've got about 5 questions for Ehab. He can look at those in a moment. So I'm going to move on to Jamie and I'll ask you to speak, Jamie.
Yes, thank you, Simon. So yes, thank you very much for your presentation. Very interested in it from a health point of view, because mushrooms and fungi can be associated with health problems, aspergillus and things like that. Yeah. And allergy. So interesting to know if you're validating everything from a health perspective to make sure that there are no adverse health effects as the materials may decompose over time. Also, the other thing, this idea that they feed on different stocks, have you made sure that there is an uptake of anything toxic into the growth? Because that's a problem for crops grown on contaminated land. They grew up the bad toxin. In the old days, it wasn't a problem with sewage because it was only poo. But nowadays, our poo is not so clean anymore. It's full of chemicals as well. So that's an issue.
Absolutely. So we take the health and well-being impact of materials very seriously. It's actually one of the reasons Biome was even founded. But looking at just the VOC side of things as a starting point, we did the VOC tests with BRE and we got an A+ score. There were literally 3 VOCs released throughout the entire 28-day test, and those were flavorants and things that are probably in our lab rather than in the material itself, because it only happened in the beginning of the test. So when you compare that with other synthetic or petrochemical insulation, it's just a huge difference. When it comes to the waste stream that is being consumed, mycelium is actually microremediating the waste. So it's turning all of the toxins and all of the hazardous substances into hydrocarbons. And those are stored in the material as completely inert hydrocarbons, which are then either fed into the soil when it's biodegraded at the end of its life, or it can be cannibalized so we can feed it to the next batch of mycelium and it'll continue to micromediate it even more. The actual waste streams that we use, we select them very carefully to make sure that they are free of toxins like that. If they do include toxins, then we identify the appropriate strain of mycelium that works with them. For example, we've got a strain that can consume construction waste, so wood that's been covered in glue or paint or things like that, that it can completely remediate that. And it depends on how long you let it grow on that waste stream to be able to remediate it. But even with that sort of time frame, we're able to produce 3,000 square meters every month from the first small-scale facility in West Somerset.
Okay, thanks, Ehab. That's really exciting. It'll be good to be able to talk some more, or perhaps we'll do that in a future program.
Mm-hmm.
So thank you very much indeed. So I'm going to move on to our next picture now. So this is Rosalie Riklova from Thermulon. So I'm going to ask Rosalie to, we're going to watch your video, so if you can be ready to come to the stage. So I'm going to hand back to Richard, and in a seamless moment of flurried.
There are quite a few questions on the Q&A, so perhaps Ehab could respond to them. There's
there's several
10.
to the dragons as well that have come in on the Q&A. So
Brilliant.
if I can ask the dragons to open up the Q&A and look at those, that would be super.
Okay.
So are you with us, Richard?
Just bear with me.
Lovely.
Hopefully you can see the video.
Yeah. 2 minutes, everybody.
Hello, dragons. I'm Rosalie Riklova, co-founder of Thermulon. In Thermulon, we have developed groundbreaking chemistry to make aerogels, the most insulating material known to man, widely available to insulate homes old and new. Our ambition is to support the UK in meeting its net zero carbon targets by 2050. Thermulon's product is a novel aerogel. Thermulon's aerogel comes in powder form, meaning that it can be mixed into lime plasters and renders to deliver its highly insulating properties. Aerogels made in this form are cheaper to make and easier to install than aerogels in boards and blankets as we know them today. Adding Thermulon to a lime plaster or render will make it a better insulator. Thermulon can improve the thermal performance measured by lambda or the K value up to 5 times at a third of the price of other aerogels. Thermulon is silica based. It's inorganic, meaning it's inherently non-combustible, even without the addition of fire retardants. Thermulon can be made from waste cullet, a waste material which is otherwise destined for landfill, saving over 240 kilograms of CO2 for every ton of glass waste that is reused. So, why Thermulon? Thermulon is the first aerogel that can be used in lime to insulate UK homes at scale. There are 29 million homes that need to be insulated by 2050, and that starts today with our first project. By winning this competition, we can take this first step with the ASBP, and we'd love that. This is Thermulon. Thank you.
So, I'm sorry that the video was a little bit choked, but so Rosalie, if I can ask you to turn your camera on, and we'll go through the same process. And so I'll ask John to come in and I'll ask you some questions.
Thank you.
Hi, Rosalie. Thank you for that. So your feedstock is it solely waste from glass manufacture or glass press?
So far it's commercially available silica, and we're experimenting with incorporating waste glass into our manufacturing process.
Okay. So the feedstock availability, say in the UK, for example, if that's where you intended to start, what's that look like in terms of volume and also the economics of that?
Again, very much in assessment stage of that. We're actually negotiating with an Irish company who have waste cullet that otherwise would have gone to landfill. It would be more than satisfactory to produce all of our aerogel from the first pilot facility, which is going to be somewhere around 1,000 meters cubed in 1 to 2 years' time.
I mean, I don't have an awful lot of experience in this, but my limited experience in the availability of silicaceous materials for this sort of aspect is that usually those that they are rejecting are going to landfill are the least able to be processed and often contain high levels of contamination, which I'll probably leave to Jamie on this. But so what's if your end product is, you know, how are you dealing with that?
So firstly, the contamination, again, we are launching actually a project on that starting now in June, in a couple of weeks' time. We should have been a bit into that, but had to delay this because of COVID. And this is very much all the things that we're investigating right now. In terms of the availability of size, we're actually focusing on glass cullet that comes in a size that's unattractive for other recycling and reuse uses, because the waste glass comes in unattractive colors, which would not matter for us because, as you could see in the video, our powder doesn't have to be transparent, it's whitish.
Okay, thank you.
Thanks, John. Mark?
Thanks, Rosalie. It's a nice presentation. I've got a couple of technical questions, probably a bit more of a commercial slant, really. I was struggling to see why in such an early stage that you're focusing on the cost of the product, because I think there's probably a lot of uncertainties in terms of what the product will actually cost when it goes to market. And if the product is good as you say, then, you know, by focusing on lower cost at the outset, you're sort of eroding some of the value in the product. You know, you don't see a company like, say, Kingspan going to market with some very cutting edge technology in their eyes and then driving the backside out of the price from day one. Plus the fact that you have, if you develop a product from a waste stream and you have to create a market for that waste stream, it very quickly generates a value for the person that's trying to sell it to you, who was previously wanting to give it to you. So I don't know what could you just tell me at what stage of the commercialization you're at and what sort of buffers you've built into the price considerations that you're presenting?
Absolutely. Thanks for the question. I dropped you there for a little bit, but I had most of the questions. So quite a bit to work on, but in terms of the price consideration. So firstly, we've been around for a year, so we're very much an early stage company. We're working on small scales now, and we're working the pricing based on how much we'll be producing already from a small scale facility. And as you say, you know, focusing too much on the price might not be the main selling point for a company that has other added value to add. And for us, that is low lambda, it is breathability, and it is non-combustibility. But at the same time, we want to commercialize the project, and price absolutely is a part of that, which is why we're playing this card too. In terms of commercialization, this is actually why we're here, because we're looking for the first projects where we could apply, for the first pilots, for the first properties where we could actually apply the aerogel mixed in with lime, which is why it's great to be here, because this is the opportunity that we're seeking, and that's the stage that the company is at right now.
And how does the additive influence the physical properties of the lime, for instance, if that's the substrate that you're adding it to?
So it affects the strength, so it affects the thickness of the layer that we can apply the lime for. It also affects drying times, and it affects how the lime cracks when it sets. So we've been experimenting with adding some fibers so far to make sure that we remediate the cracking and to make sure that we adhere to the base layer. We've tested on brick so far. And what's ahead of us is just loads more of that. You know, we have to test it with different primers. We have to test it with different bricks, and we actually have to go through the process of testing all of these. We know in theory that aerogels can be applied for up to 50 millimeters layer, to my knowledge. And again, this is going to depend on the aerogel loading in the line, and that's all ahead of us.
Okay, thank you. That's fantastic. So, Jamie?
Yes, thank you very much for your interesting presentation. So the question for me always would be, in materials, what happens to them over time? Do they degrade? Do things come out that you wouldn't want? So, for example, with foams, one of the problems is that the flame retardants can leach out slowly over time and go into the house dust. So can you get glass fibers appearing in the indoor air? Because glass fibers can be quite, you know, silicosis and all sorts of lung problems. Have you looked at that?
Yeah, and no, absolutely, they do not. So they're chemically fixed into the lime, they're chemically inert, and they do not leach into the environment. And the good thing about it is our aerogel is silica based, so it is inorganic and inherently non-combustible. So we don't have to treat it with any fire retardants. And it comes with the benefits of having lime, which is, you know, which is alkaline and very unfriendly to mold growth and fungi growth and the like. So it is beneficial to the internal environment as well.
Interesting. Sounds fascinating. Thank you so much. That's fantastic. All right. So we're going to have to move on now. So thank you, Rosalie. That's brilliant. So stay with us. And there are a pile of questions coming in from everybody. There's some a pile of work for everybody to do. So we can always catch up on another, of course, on another show. But now I'm going to ask Steve to turn his camera. Oh, no, hang on. We're going to watch the video, aren't we, from GeoCell, Richard. So I'm hoping that you're teed up and ready to go. So keep your questions coming in. Thank you for these. We'll make sure that we'll answer all of these. We may not get around to them whilst we're live, but we definitely will ask everybody to complete them, and then we'll send them to you. So, thank you very much, Richard. So we'll watch the video and then have 2 minutes. Yeah, thank you.
Mike Y, based down here in Devon. We are builders merchants selling natural, sustainable building materials. The product that we're pitching this afternoon is GeoCell. It's foam glass. It is an insulation that's used for floor foundations, as lightweight fill, used in landscaping and for French drains. Why is it innovative? It's made from 100% waste glass, which means it reduces what goes into landfill, it's completely inert, and it's recyclable at end of life. We feel that this product should be put forward because it's ecologically beneficial by reducing landfill. It's more cost effective than modern insulations when you include installation cost. For underfloor or foundation insulation, it's a single layer and it's a multifunctional product. It insulates, it's load bearing, it's inert, and it's non-capillary. So it fulfills a number of roles without having to have a number of different products. And at end of life, it can then be recycled itself back into more insulation. Thank you very much for listening.
Excellent. Okay, so Steve Rugger is on the line here and will join us now. And so we'll run through some questions with him and our dragons. So Steve, are you there?
I am, yes. I think it says the host stopped my video, so I can't start it again.
Oh,
how about now?
Oh, there you go.
Yeah.
Fantastic.
Oh, there we are.
Okay, John, over to you.
Yeah, thank you, Steve. Similar question to my previous question on the source of and the economics of the waste glass. In terms of the availability and in terms of the economics of that in feeding into your material, and then of course the economics of the conversion into the material you've actually ended up with. What does that look like?
It's a profitable operation. The waste glass is readily available, and it is already a commercial product, just not massively well known in the UK currently. So it has been used in Europe, and there is a margin in there, relatively good margin.
And is it the usual? I mean, it's always the case, isn't it, that as soon as the waste industry wakes up to the fact that a raw material is worth something, as opposed to having to do with it now, has that been factored into your costs?
It has, yes, yeah, that's fully factored in. So as I say, it is a commercial operation as we speak over in Europe. So the cost of the raw material is factored in, cost of processing, and cost to end user as well.
And the process itself to make it, in terms of the energy to make it, what does that look like?
It's a heating process. Obviously, they use 100% waste glass. I don't have cost figures for it as such, but it's ground to a powder. Waste glass is ground to a powder. It's mixed with glycerine as a foaming agent and heated, and then as it cools, it forms the aggregate.
Okay, great. Thank you, Steve.
Okay.
Mark?
I've actually used this product, so I've put my hand in my pocket and paid for it and used it. So unfortunately, that's, I can't say that for the other two, but they're at different stage in their life cycle. I guess the question would be, what's stopping this product being as popular or as widely used as it could be in the UK?
I think it's the pushback from the traditional PIR manufacturers and lack of education in the building industry. I have to say, our experience is that those that have used it, having been persuaded to use it first time, then come back and use it again. So I think education is a major stumbling block really for its use in the UK.
And when do you think a UK manufacturing facility would be operational?
Once there is enough use to make a plant economic to run, and use is growing all the time. I don't think we're there yet, but there will be a tipping point at which it will be economic to run a plant in the UK.
So at the minute, all the foam glass that's used in the UK is imported?
It is all imported from Europe, unfortunately.
And what sort of payload would you get in terms of tonnage?
Tonnage, we talk in cubic meters, right, because a cubic meter weighs 150 kilos. So we would get 90 cubic meters in a lorry for a full load. So it's
more weight than I thought.
Yeah, yeah. There's a cubic meter.
I tried to lift a cubic meter of it. I know it's heavier than it looks.
It is, yeah. But in terms of transporting it is very, very light, and so transport costs are fairly low.
All right, thanks, Steve.
Years away from a plant in the UK, or decades away?
Whispers are years and less than a decade, possibly 3 to 5 years.
Thanks, Mark. So, Jamie.
Yes, thank you, Steve, for your presentation. Just to check my understanding, did you say this is used in flooring?
It's used in underfloor insulation.
Yes. So is the person's feet in touch with it, or is there something?
No, it's a sub-layer. So,
it's a sub-layer. Okay.
You would put, and we use it a lot with lime screed over it for older properties. You can put a damp-proof membrane and modern.
So there isn't an issue of the material coming out into the room as a particulate?
No, once it's installed, it is then enveloped in other products. So there's no contact at all.
Okay. Yeah, that's all I had to ask. Thank you.
That's excellent. Okay, well, we'll bang on time. So thank you very, very much. Three fantastic pitches, three fantastic products. I'm pleased it's not me that's having to try and pick which one is going to win. So I'm not allowed to vote, so I'm pleased with that. So I'd like you all to have a think on which products your favourite. We're going to ask the dragons to consider their decisions and share them with us. And we're going to share a poll with you so that we can you can vote. So I'm going to hand you back to Richard at this point. Keep your questions coming in. We'll ask everybody to keep an eye on the Q&A. And so I'm going to hand you back to Richard to
the poll.
Run the poll. And perhaps you can have a think, dragons, and we're going to ask you just to say in one sentence why you've chosen that product. So thank you very much for responding to the poll. We're all coming in nicely. So you'll be pleased to know that our next Dragon's Den is on plastics and of course packaging. And this time we'll have 3 lady dragons and bring the balance back. I'm sorry about that. And so on the 17th of September at 2 o'clock, we'll be hosting our next Dragon's Den on packaging, and we'll hopefully be joined by Catherine Adams and Lynn Potter and Stephanie from Wienerberger. So put that date in your diary, 2 o'clock, 17th of September. So I think all the votes are coming in now. So I'm going to hand you back to the dragons. So John, perhaps I'm going to ask you to come in, make your decision, and tell us why.
Yeah, I mean, 3 great pictures, and thank you very much for that. Clearly, a lot of effort's been put in on all parts here. I mean, I applaud any innovation which uses waste into a useful product. So there are fantastic technologies. However, I think my personal favourite, and I guess my slight bias is always towards a bioprocess, because I think always nature has lots more to teach us, and there's lots more scope in those bioprocesses often than in the traditional processes. So I think it is the mycelium biome for me, because it's bio-based, it's sustainable, and I think there's clearly lots of scope here in terms of going forward as to what you can do with this material. So that's my vote.
Okay, thank you very much, sir. Over to you, Mark.
Thank you. I thought all 3 were very compelling. I think Thermalon is just a little bit early stage for me, if I'm honest, and I think there's a bright future for that brand, but I don't think it would be developed enough for me to vote for it at the minute. I'm a strong believer in natural materials, and I think biome is the one that's going to get it for me. I think the one thing that grabbed me, and it is a bit of a leap of faith, because I'm still a little bit skeptical about the thermal conductivities that can be achieved. But if they can achieve consistent thermal conductivity at 0.024 with a natural biodegradable material, and it's a game changer. I just hope that is deliverable. The GeoCell is a great product, and I think it's got a great future, and it doesn't need me to support it to give it a leg up. So it's biome for me.
Okay, excellent. Thank you, Mark. Jamie?
Thank you very much for asking me to vote on this. I have to say I find it very difficult to decide, because they all seem very innovative and very interesting. My concern about the biome, it's more of a gap in the knowledge, and it could probably be answered. VOCs were mentioned, but again, I come back to the allergy problem. Are there particulates that might cause allergies? That I couldn't tell, and with that lack of information, I'm sort of skewed towards the other 2, and there I have my difficulty, because they both seem very interesting using glass as an insulation material. I have great difficulty making the distinction between the Thermalon and the GeoCell. I quite like the GeoCell because it seems to be very pragmatic and quite advanced. So it's a hard one. I'll put my vote on that one.
Okay, thank you, Jamie. You're very considered. Thank you very much indeed, sir. Okay, excellent. So we have a winner. So thank you, EHAB. So drum roll, drum roll. We're giving you the prize and popping you through to the grand final, which will be next year. So it'd be great to work with you through that process, and I'm sure our dragons would like to pick up with you offline and perhaps work together. John has offered to help out with some time and efforts on developing all of your products. So let's all work together.
Thank you very much, everyone. Really appreciate it.
Fantastic. So what's the exciting next stage for you, EHAB?
Well, we've got our crowdfunding campaign that we've just launched a couple of weeks ago, actually last week. And that's gone live now. It's going really well. We're already almost at 80%
wow, brilliant.
Funded. So that's really
So just
exciting.
need a final push.
Yes. And we've got our facility being set up in West Somerset. That's taken all of our energy at the moment. So that's our focus.
Okay, fantastic. All right, well, that's very, very exciting. So,
Thank
Richard?
You. Yeah, if we could just thank, obviously, Thermulon and GeoCell.
Absolutely, yeah.
And I'll just share. So this is the
applause.
Here are the results of the audience vote. There we are.
Okay, so we have a clear winner. Okay, so you have the audience vote too. So double whammy, great. So commiserations to our two worthy pitchers, and perhaps I can ask Rosalie to tell us a little bit more about the project that she's going to be working on. That'd be interesting to hear. So perhaps if I can ask you to take your camera off and just say a couple of words. Yeah, hi there. Yeah, excellent. Thanks for coming back in. So just tell us a little bit about your project.
Yeah, so the project that we would like to work on is actually with ASBP's very own Harry Paticus, who is doing his step-by-step NRFit retrofit, and he might look into identifying some sites in his home if that would be at all suitable. But we're definitely, that there's lots of variables at play, so we're definitely keen if there's somebody who would like to install, for example, a single wall in their home, or if there's a line manufacturer who's keen to experiment with mixing in aerogels. That's another project that we'd absolutely love to work on. So thank you, ASBP Network, and just ping me a message or drop me an email and I'll stay in touch. Cheers.
Fantastic. Thanks ever so much.
Thank you.
And Steve, a final word from yourself? We're all winners, really.
Yeah, thank you very much for the opportunity. Yeah, thank you for the opportunity, and congratulations to EHAB. Yeah, worthy winner, I think. But yeah, I think all good products.
Oh, thank you. Thank you, Steve. That's very generous. Much appreciated. Thanks for your time. Stay well down there.
And you.
All right.
Yep. Thanks.
Well, we're just going to remind you about the rest of the series of the Dragon's Den, and ask you to put those dates in your diary. They're free events, of course. I think this one's been quite fun. We've learned a few things along the way. There's one or two things that didn't quite work out as well as we'd hoped. We had hoped to take more of your questions in a live Q&A, but we're up against the clock at the moment. So let me just move this away. Yeah, so 17th September, 3 lady dragons, single-use plastics and packaging. So we'll be looking for new and exciting products in that area. And I'm really pleased to say that the Plastics in Construction group has grown nicely. We've got a new member, so I'd like to welcome Muller Europe, sorry about that, put my teeth in, Muller Europe to to the group, and so their focus is around copper and life cycle analysis, and they're trying to understand if they can bring 100% recycled copper into their feedstock. So they're doing some exciting things there. So it's a really progressive and positive addition to the group. And I'm trying to convince them to pitch for a product in October around building services. In November, we're on flooring, finishes and paints. So any interesting products there, we're on the lookout for those. So please ping me a note. And then in December, just before Christmas, we're looking at more sort of building elements. And so one of our members, Barico, is developing 100% plastic-free windows. And that in itself is a really interesting case study. It's been a real journey for them, trying to understand how they can look at their packaging and issues around bioplastic products sticking to frames. And so it's been quite a journey for them. So we'll be asking them to share a little bit from that. So find out more on our website, of course, and sign up to our newsletter. Please consider joining the ASBP. We're always welcome new members, and we're pleased to be growing in these rather difficult times. It would have been nice to put everybody up on camera, but we decided perhaps not to do that this time around. I'm missing seeing everybody. I quite like to have a chat and a glass of wine and a conversation with everybody who's here with us, but maybe we can do that next year at the grand final. So it remains for me to say thank you very, very much to our dragons. So they've been a fantastic set of dragons and very well behaved. No fire, no flame, but so thank you to those, and thank you to our pitchers, and congratulations once again to EHAB. Fantastic product. We look forward to hearing that you've met your targets and look forward to working with you and updating everybody on your progress as you grow.
Thank you very much
indeed for staying with us. Richard, are there any final words you would like to add in?
No, just to say that obviously the intro guide will be live on our website in the next half an hour after our final edits. So.
Okay, fantastic. Yeah, so thank you very, very much, everybody, for joining our webinar today. Next week, we're looking at healthy buildings. So this is a subject, I think, close to everybody's heart here. So next Thursday, 11 o'clock, we'll be talking to two of the Alliance's members. So Tim from Waverton and John from PPM Technologies. Some really interesting kit that these guys have got to measure indoor air quality and to set parameters for measuring indoor air quality. So if there is a particular problem, a health condition or something that there is an issue around, then they have got the kit to help sort of work out what's going on. So we had some really interesting reports about excessive formaldehyde in school classrooms, and I got in touch with the developer, and he had no idea what formaldehyde was, how much was good, what was bad, where it came from, or anything. And so that prompted us to write a guide to formaldehyde, what it is, and how much is good for me and how much is not good for me. But there's a fantastic array of data that these guys have got. So Waverton have got results from some 5,000 indoor air quality studies. So we'll be sharing a lot of data with you guys, and PPM Technology have got some really interesting kit. So they're based in Wales, so they're still locked down, of course, at the moment, but hopefully John will be able to join us, and that'll be good. So thank you ever so much, everybody, for joining us. If you've got any questions, still pop them on. We'll stay online now, but we're going to finish this. And thank you very much for coming, and look forward to seeing you virtually or otherwise soon. So thank you.